Hi everybody, my name is Miguel, and today I'm going to show you how to integrate Chainloop with an existing CI pipeline. I'm going to be using this repository, which has already a release process using GitHub Actions. And what we do here is we build a binary, we create a container image, we sign everything using cosign, we create an SBOM, and put the result in a GitHub release. And from the point of view of a user, this is great because you can come to this repo, you can download the piece of software, and then you can verify its provenance, for example. But from the point of view of an organization, all this information is in a silo, and it makes it very hard to audit. It is very hard to do anything useful with it. And it gets worse the more CI pipelines that you add. So that's why we want to enable Chainloop in this case, because by default, Chainloop will break all those silos by offering a central location. So all that metadata and artifacts will get stored in a central location. Then it will add an additional layer of trust by creating a tamper-resistant attestation. And once you have all that data that you can trust going through, you can decide what to do with it. And you might want to enable third-party integrations to, for example, analyze the bill of materials. But what's really more interesting about Chainloop is the fact that you, as an operator, can declare how the attestation process looks like. So for example, before Chainloop, you might have some teams that are creating an SBOM using CycloneDX format. Some of them might be using SPDX. Some of them might not be doing any of those. But you can now, using Chainloop, you can declare a specific format. You can propagate that requirement and you can enforce it. And you do that by using workflow contracts. And that's what we're going to be doing during the demo. So how do you use Chainloop? So Chainloop has two main pieces, a control plane that is a service and a CLI that you use to operate with the control plane, but also to run the attestation process in the CLI. So you will download the CLI locally, and then you will authenticate against the control plane. The last step will be to add your own OCI registry because Chainloop doesn't store the data. You will add your own OCI registry, so all that metadata will end up there. And you can use any of a provider of your choice. In my case, I have already configured Chainloop and logged in, and I'm using Google's artifact registry. The integration process usually has two steps. The first one is that an operator will create a workflow and register a contract in the control plane, and then the development team will enable the attestation processing on their CI. And we're going to be doing that, but in two steps. We are going to be creating a contract, a very basic one, pretty much empty, that only tells you that needs to run in GitHub Actions. And by adding this, it will enforce that happens in a GitHub action, that the station happens in a GitHub action, and also will return environment information automatically. So the first thing that we're going to do is to create a workflow with a name, a project, and this first version of the contract. Okay. So now we have a workflow and a contract in the control plane. How do we integrate it in the CI? So as I mentioned before, the Chainloop CLI is also used in the CI, but you will use the Chainloop attestation subcommand. And the Chainloop attestation subcommand has different actions that, as you can tell, looks a lot like Git. And this is on purpose because the workflow is very similar. You will initialize an attestation, then you will add materials, and then push the result. But as you can see here, there is a requirement, which is a robot account token, which is the way that the attestation process is going to authenticate with the control plane. So we need to do that. So to do that, we use the CLI, and we use workflow, robot, account, create with this specific workflow. And here it is. We have a robot account that we can use. Good. Now we can go to the repository, and add it as a secret. Here it is. So what's next? Now we have the token. What else do we need? So the next thing that we need to do is to basically update the release process in the repository. And I have a file already for that, and this is the difference. So we're updating the GitHub workflow, and we add new steps. The first one installs Chainloop. The second one initialize the attestation. And finally, it will craft it and push the attestation to the control plane signed by cosign key. And as you can see, the robot account token is imported. And we're gonna, okay, so let's take a look at the action now. We're releasing. And now we have installed Chainloop, which downloaded the CLI and then verified signature. It ran Chainloop attestation in it and automatically discover what's the workflow associated with this attestation. And now it's building the binary. So what can we do in the meantime? So we can use Chainloop workflow ls, and this is the list of workflows that we have on one, but we can also list the runs. So in this case, we have a workflow run that is in progress. But what's interesting is that we already have the link to the job, for example. And we can also describe it. And it is in progress. Let's try again. There it is. It finished. This is the result of an attestation that just happened in GitHub Actions. And we have when it started, when it finished, we have environment information that came because in the contract we said that it was a GitHub action. So we know who launched it, we have the commit ID. We can actually see the result that is sent, and it's an in toto statement. And something you might have seen here is that it says verified false. And what does this mean? What this means is that because it is signed, we can actually verify it against a public key. And now we're verifying the content. Eventually we will have keyless signing and verifying, but for now you need to use asymmetric keys. So this is good. We already have information that's coming through the control plane, but we want to add materials, right? So what we're going to be doing is updating the contract with a new set of requirements. And we have a new contract here that basically adds 3 new materials. A reference to a container image, an artifact called binary, and Cyclone DX SBOM in JSON format. So let's do that. How do we do that? So what we're going to do is update the contract. Well, for contract update, we're going to update this one, and we're going to use Chainloop demo contract v2. And here it is. We just updated the contract. There's a new revision. This gets version. And we have these 3 new requirements. So what's next? We need to update the GitHub action. And we do that by pushing a new release. And what did we do here? So we updated, now we are initializing a new revision, and we are executing Chainloop attestation add with the 3 required materials before we push. Let's go back here. This is running. It's gonna run. This is gonna take a little bit. We're gonna speed it up. Okay, so we're done. And what do we have here? So we have here now, we can do Chainloop workflow run less, workflow run describe, the latest run, and here it is. Now we have a new run. But what's new about this one is this. We have a new materials table. And this is specifically what we told them, we said that we wanted to receive as part of the contract. And what's very interesting about Chainloop is the fact that the developer, if we take a look at how the SBOM or the container image was added, what the developer did was Chainloop attestation add with the container image with a tag, but automatically it found the digest of the container image. Same with the SBOM. You pass the SBOM via a file, but automatically was uploaded to a cache. And this is very interesting because that means that all the best practices that you're supposed to do to make sure that you can trust that data, it happens automatically under the hood. And in fact, for example, this file, which is an artifact, you can download it. You can use Chainloop artifact download, and you download it by digest. We're done. We managed to integrate our release process in with Chainloop. So now when there is a new release, automatically the SBOM, the reference to the container image, the binary will be stored in our RCA registry alongside the new sign attestation. So this will happen automatically. If we need to add new requirements, we just need to update the contract and apply the changes downstream. If we want to add new pipelines, you can easily do it. Doesn't need to be GitHub. GitHub is just an example. Chainloop works in any runner. You could also add a third-party integration, enable a third-party integration. So for example, the Cyclone DX that we are already receiving, we could analyze it. We could use the beta UI that we're building to get some visibility on your software supply chain. But for now, I'm gonna leave it here for this demo, and those are topics for future videos. So if you have any question, please reach out, and I really appreciate your time. I hope that you found it useful. Thank you.